Welcome to the CubeWorks Industrial Efficiency Series. Your facility's electricity bill last month was 1.4 million pesos. What was the single biggest contributor to that number? If you cannot answer that in 30 seconds, you are managing almost 17 million pesos in annual energy spend completely blind. Submetering solves this. It does not reduce your energy use automatically. Instead, it measures exact consumption at the localized level, making the invisible visible. Raw visibility is the starting point for any mechanical or operational improvement in a facility. Consider how you manage every other major cost in your facility. Raw materials are tracked by SKU and batch. Labor is tracked by shift and department. Maintenance has a ledger for every asset and failure type. Energy, however, arrives as one opaque number from a single utility meter. You know the total cost, and you know nothing else. You do not know if your compressors are responsible for 22% of your bill or 35%. You do not know if the night shift is leaving production lines running without properly shutting them down during breaks. The Department of Energy now requires designated establishments to report precise energy consumption. Facilities without proper infrastructure scramble to compile this data from manual readings and estimates, consuming staff time and producing highly questionable data. Submetering replaces this guesswork by providing precise consumption data continuously and automatically. This granular measurement standardizes how we monitor power, bringing energy into the same precise ledger system you already use for all other operational costs. The technical practice of submetering involves measuring electricity consumption at specific points below your main utility service entrance. This architecture mirrors your electrical network. The main utility meter acts as the root node, capturing total consumption. Below it, branches represent high-level zone meters, covering major facility blocks, subdividing into specific system meters, and finally into individual machine-level leaf nodes. You do not need to build out this complete facility-wide tree on day one. Installing just 4 zone meters immediately identifies which broad area of the plant consumes the highest fraction of your energy. This hierarchical architecture systematically narrows the mathematical location of energy waste from somewhere in the building down to a specific machine. Total energy consumption tells you what you spend. It does not dictate whether your facility is actually performing efficiently. To measure true engineering efficiency, we use specific energy intensity, or SEI. This is the energy consumed per unit of output, normalizing your data against changing production volumes. A paradox. From January to February, energy consumption increased from 12,400 to 13,200 kilowatt-hours, but production volume increased faster. Dividing energy by output, the SEI metric drops from 40 to 38.3. Overall efficiency improved despite the higher utility bill. Modern industrial IoT platforms merge physical data from your submeters with software production counts to calculate and plot these SEI trends automatically. Tracking SEI shifts your facility's energy strategy from simply reacting to an expensive monthly bill to actively optimizing actual production efficiency. Waste clusters into 5 predictable patterns: ghost loads consuming energy during off hours, inefficient machines drawing excess power, compressed air leaks cycling needlessly, inefficient shifts showing behavioral discrepancies, and utility oversizing, where mismatched assets short cycle while struggling to manage small capacities. Without granular tracking, these 5 distinct, solvable mechanical and behavioral problems blend together into one unsolvable aggregate utility bill. Installing this network is a physical reality. It requires qualified electricians working safely inside energized electrical panels. Step 1 is mapping out your entire electrical distribution. You need a single line diagram from the utility meter down to the end loads before purchasing any hardware. Step 2 is selecting the proper measurement technology. For most applications, specify a multifunction energy meter utilizing clamp-on current transformers and standard communication protocols. Step 3 is executing the physical installation. To eliminate safety risks, this work is completed during the planned production shutdown. Step 5 is commissioning the hardware. Each newly installed meter is cross-referenced against known, expected machine loads to verify accuracy. Step 5 is connecting the meters to your gateway, verifying that clean, properly scaled data is flowing to your dashboard. Following a rigid physical installation protocol ensures the data reaching your dashboard matches the actual electrical load on the floor. Submetering hardware without a dedicated review protocol is just useless data collection. Action requires an administrative structure. This diagram outlines a strict 45-minute monthly energy review workflow designed to translate your raw numbers into actual operational decisions. The first 10 minutes are spent reviewing total consumption and cost by zone against historical baselines to spot major shifts. The next 10 minutes are used to analyze specific SEI trends to pinpoint exactly which production lines degraded in efficiency. The third 10-minute block is for investigating all non-production energy usage, catching new ghost loads or poor shutdown procedures. The fourth element dedicates 10 minutes to evaluating core performance of compressors and cooling towers against design baselines. The final 5 minutes are reserved for reviewing the measurable impact of deployed action items. By systematically identifying behavioral ghost loads, machine wear, and utility system drift every 30 days, facilities can address the specific waste patterns that typically account for up to 30%. Success relies on implementing zone meters, tracking specific energy intensity, hunting the 5 predictable waste patterns, and executing a strict monthly review. Your immediate task is to draw out your facility's electrical single-line diagram. That drawing is your baseline submetering plan. Next month, we explore infrastructure losses through non-revenue water, mapping out exactly why water districts lose massive volume before anyone pays for it. Subscribe to uncover more hidden operational waste. Every facility possesses hidden waste. Structured visibility is the only weapon capable of eliminating it.